Hello. Hello. So let's talk about extreme complex fractions. Extreme complex fractions. Complex fractions are a mixture of operations in a fraction. So when you look at this numerator, what do we see? We see that we got this whole number plus this mixed number, divided by this denominator that has this whole number minus a mixed number. So let's make it easier on ourselves. Let's just rewrite it where it's easier to read. So what I'm going to do is I'm going to separate the numerator from the denominator. That way I can work on it in parts. So here we go. So now that I have that done, let's clean up the numerator first, and then we'll clean up the denominator. Over here in the numerator, I see that I have this whole number, and we know that a whole number is seen to be over 1. So this is going to be helpful whenever we combine the whole number and this fraction. This fraction here is a mixed number. I know that you can add mixed numbers and whole numbers. You just have to be very, very careful when you do it that way, because you tend to lose a number when you subtract, and your answers may come out wrong if you forget that step. So I'm going to just keep it basic and simple. I'm going to convert this mixed number to an improper. So that means I'm going to bring this 5 over 1 down. And what I know about a mixed number being converted to a whole to an improper fraction, I know that the denominator doesn't change. So let's go ahead and write it. So now we ask ourselves, the denominator times this whole number is 15, and then we add that product to the numerator, which gives us 16. So now I got this cleaned up. I'm going to go ahead and bring down this division bar, and let's clean up the denominator. And in the denominator, I see that I got this whole number, so I'm going to go ahead and put it over 1. This will just help me whenever I go combine them. And let's bring down this minus. And again, this is a mixed number, so when I have a mixed number, let's go ahead and convert it to improper. And what I know don't change is the denominator. And then I follow the rules. I say the denominator times the whole number. In this case, is 3 times 1 is 3. Then add it to the numerator. 3 plus 1 is 4. So now I can combine each part. I can combine the numerator. Whenever you add or subtract fractions, we have to have a least common denominator, meaning that a number that both the denominator and will go into. Maybe not the same amount of times, but they will go into it. I know 1 will go into 5 and 5 will go into 5. So 5 will be my least common denominator. That means I only have to change this one fraction. I got to find what it will take to make 5 in the denominator. That means 1 times what? Well, that's 5. And what I do to the bottom, I do to the top. And then we go ahead and bring down the rest of this equation. There we go. And so now I can go ahead and combine these, and I can go ahead and rewrite this. And if you notice, I like to finish this side up before I work on this other one. So I have 5 times 5 is 25 over 1 times 5. And that what we wanted in the denominator was 5, so we did it right. So now that it's all over the same denominator, I'm going to write an extra step. I'm going to go ahead and put the 25 plus 16 all over 5. That way, when I combined, I don't try to combine the denominators. It's a common error. It tends to happen on accident. So now I have 25 plus 16, which we know is 41. And guys, if you don't see it right off the top of your head, that is okay. I encourage you to go over to the side, line it up, 25 over 16, and add it. That is not a big deal if you need to do that. I know that this is a mixed number, or excuse me, I apologize. This is a improper fraction, and it can be converted to mixed number, but I want to wait because I want to combine these together before I do all that. So let's just bring this division sign down. Now let's work on this other side. And this works out great, me putting this arrow here, because it helps divide this up and be less messy. So what I got, let's just scroll up just a little bit. I got 2 over 1 minus that 4/3. Well, we still have to follow by the rules. We have to have a least common denominator, and my denominator is a 1 and a 3. So what is a number that they both will go into? Not the same amount of times, but they both will go into. I know 1 will go into 3, and 3 will go into 3. So that means 3 is my least common denominator. And since this already has 3, I don't have to change this fraction. It's this one I got to change. So I asked myself, what do I multiply this denominator by to get it to be 3? Well, in this case, it's just 3. What you do to the bottom, you do to the top. 3 times 2 is 6. 3 times 1 is 3. Yay, my denominators are the same. That's what I wanted. So now I can just rewrite this one more time. I got 6 minus 4 all over 3. 6 minus 4 is 2, and since 6 is the larger number, it's a positive because it's whatever the sign is on the larger. So I got 2/3. Yay. So now we can follow the rules of division of fractions since we have it all cleaned up. And the rules on division of fractions says we keep the first term the same. Changed division to multiplication. And we flip the second term. So let's do that. I got 41 over 5 times 3 over 2. Now, whenever we're multiplying fractions, we always go, is there a number on top that will reduce with the number on bottom? Well, I'm looking at the numbers on bottom. 5 and 2 are prime, and neither one of these will go with the number on top. So as long as that is the case, then that means I can just move on to the next step. I got 41 times 3. So we know that 3 times 1 is 3, and 3 times 4 is 12, so it's 123. 5 times 2 is 10. So here's my answer in a improper fraction. So make sure and read what the directions tell you to do. Let's go ahead and make another step, and let's go ahead and write it as a mixed number. So we say 10 goes into 123 12 times, right? That gives me 120. What don't change is the denominator, so I can go ahead and write that down too. 10 times 12 is 120, minus this 123 leaves me with 3. So now I got it in mixed number. Let's write it in decimal. Well, this 12 is the whole number, so we know it goes in front of the decimal. And 3 is over 10, so that means it's in the 10th place. So now I've not only written it in improper, mixed number, now decimal. And if you notice, I did approximately, because whenever you convert to decimals, a lot of times it's not nice and clean. In this case, it was, but it's not always. So approximately is a good representation as saying equivalent almost to, and that keeps you from saying exactly when there is another number to round to. Guys, if you have any other questions, please contact me. I'd be happy to work out more math problems, examples, or explain the ones that did work out, or help you be successful in math is my goal. Thank you.